Okay, allow me share my screen. It's already in my view. Okay, thank you. Hello everyone. My name is Mugabe Samuel, and I'll be taking you through our end of semester presentation for computer vision, project, class project, which is mainly about garden monitoring tool, comparing the performance of KNN models and also the deep learning models for classification of maize, cassava, sugarcane, and then also the grass that is in the pictures. Yeah, so I'll be the one presenting. Okay, these are our table of contents. Allow me go into the introduction straight away. Now, of course, deep learning models are being applied almost in all segments of computer vision. They sort of outperform the traditional methods, and this paper is sort of we're describing the development of a monitoring tool using KNN and then the deep learning models. Then we shall compare the two approaches and see which one performs better. Now, the aim of this study is mainly to classify the crops and determine which one is maize, which one is cassava, sugarcane, and grass, and so on. Now, identifying the grass, of course, is what we're mainly looking at here, which would help for weed detection. Now, deep learning techniques have shown they're very promising and identifying the weeds in the pictures. Okay, the motivation for this project was mainly, identifying the weeds that are in the garden using computer vision, classifying crops in the garden using crop monitoring tools, and then resource management. Garden monitoring tools are also essential for safeguarding plants and also the well-being for activity. Yes. Yeah, so first, before we started, of course, we were provided a video with showing a garden whereby we were able to extract it, as we shall see later in the methodology. We extracted frames and then we were able to, sort of annotate and then process these frames. But before all that, we carried out a literature review. I looked at 10 papers and reviewed each of them. They are well documented. You'll find that in the report. Right now, allow me to continue to the methodology. Now, like I was saying, we extracted the frames and then we applied well, after we first we annotated which ones were the crops, which one was the maize, cassava, bananas, and grasses for a number of photos were annotated. And then we pre-processed all these, we augmented them so as to increase their size and so on and so forth. And then also we had to feed this into the KNN models and also the convolutional neural networks. Then the models were trained and evaluated on the data set, and then these results were compared. Okay, so here I'm showing mainly how the annotation went. I used a tool called label IMG. You just fire it up. You have your classes. Now these were our classes that we had. We had maize, cassava, bananas, grass, coffee, and sugarcane, eucalyptus. And then you draw these bounding boxes. For example, this is a bounding box for cassava. This is a bounding box for eucalyptus, and so on and so forth. It's quite manual work and it took some time. Yeah, and then now this is the grass. What you see down here is what you classify as grass. Now, after annotating these images, these were saved into a labeled images. You can save using YOLO format, whichever format you want. Yeah, this is mainly what I'm explaining here. And then the annotations were saved in CSV format. So this is an example of a labeled image. Just down here, you can see that the bounding box, this is the bounding box, this and that, then the height, and then also the width. Now, this is what you feed into the KNN. and then I evaluate according to the labels. Okay, so now, for example, here we have a crop on the left. I think you can see it. And then we had to extract out the edges from this image. Now you can see the extraction, the edge extraction process was it was fair. It was fair, as you can see, it sort of brings out what we want. And then we came up with a color histogram for this image, where you can see the different colors that are mainly contained in the image. Then also the saved features were also extracted. Now in the KNN models, remember the features were first hand crafted. You go image by image and you classify which one is classified, which one is grass, and so on and so forth. And then this KNN was evaluated according to precision and recall and F1 scores. Also, hyperparameter tuning was done on the KNN models, sort of varying the number of neighbors to see how it performs. And this is what we are mainly showing here. Now, this is accuracy versus the number of neighbors. Now you can see that as the number of neighbors increased, the accuracy was going down. The number of neighbors increases, the accuracy goes down. And then also the loss, as you can see, the blue is the train set, and then the orange is the validation set. Yep, that is the score. These are the scores for the KNN models, which we are going to compare. We shall compare, of course, when they were tuned, hyperparameter tuned, they sort of performed better than the previous that were not tuned. Of course, hyperparameter tuning is always important in machine learning. It's always an important step. It has been proven that it improves the results. So as you can see, the accuracy sort of improved when we tuned. Now we fired up the CNN models, the CNN model, which we developed, and achieved an accuracy of 94%, which is so high, but I think you might have seen even CNN models that perform better than this. And of course, it outperformed the KNN that we used at first. Now, this is the model architecture for the CNN. You can see the convolution layer. Then we applied some min-max pooling. We applied some max pooling. Then we flattened. We had a dense layer in there, and so on and so forth. Now, when we trained the CNN, you realize that as the number of epochs went up, the accuracy also went up, but then it reaches somewhere and it's on a standstill, and it sort of reaches like a plateau, reaches the plateau at around 5 epochs. Yes, and that was measured on the train and validation data set. This is mainly the accuracy, which is way higher than the KNN. Yeah, so that was mainly it. And then for our future works, we're looking at XAI, applying XAI. Most of these models are looked at as black box models. You don't know why it predicts this and this. You don't know why it predicts it calls this cassava, it calls this banana. You don't know why. But when you apply XAI, it sort of gives feature importance, that it extracts which features mainly affect the model prediction. And then you're able to know that this feature is what made this model predict this as cassava. This feature is what made this predict as a wheat. Now, XAI is important to sort of develop user trust, consumer trust, such that these machine learning models can be consumed, such that they can be trusted by the users. Then also future works, we had, we sort of, because it's a manual process that we use to label the images, we sort of didn't label very many images, but it is advised to label as many images as possible. Other than that, thank you so much for listening. God bless you.